Okay, Chebychev's theorem. Don't have to get into too much detail about this, but the reason why I'm mentioning this is because the next thing that we will do is the empirical rule, which will validate this theorem. So let's say k is some arbitrary number, but can't be equal to 1. It has to be bigger than 0. So if k is not equal to 1, and if k is bigger than 0, in other words, it has to be bigger than 1, then at least 1 minus 1 over k squared % of the observations in the data will lie within k standard deviations from the mean. In other words, according to the theorem, if the mean is right here, clearly I can't pick 1. Because k can't be 1. Let's just say k is 2. So I'm going 2 standard deviations to the right and 2 standard deviations to the left. Do you agree? So k in this case is 2. What does the theorem state? The theorem tells us at least 1 minus 1 over k squared % of all the data points will lie right there. Good. Between those two values. What is 1 minus 1 over k squared? %. So according to the theorem, at least 75% of the observations So at least 75% of the observations will lie within 2 standard deviations from the mean, in the sense 2 standard deviations to the right, 2 standard deviations to the left. You would have 75% of the observations. Does that make sense? Okay, now, what would happen if I increase the number of standard deviations? Would that percentage go up or will it go down? It will go up. So if I keep on going, eventually it has to hit 100%, right? So if you have a data with mean 2 and standard deviation 0.5, if you eventually keep on increasing how far you go from the mean, you're going to cover all the observations in the sample. Does that make sense? So that's what this theorem means. It's a quick way to realize, okay, what % of data is going to lie. The key word here is not saying exactly 75%, at least 75%, in the sense 75% or more. Good. Okay. So we have a statistics exam. The average is 82. The standard deviation is 3. I hope this is the case next week. We do realize that there is an exam coming from. So we want to interpret Chebychev's theorem for k equals 4. I'm going to give you a second, and you can do the calculation and give me your interpretation. Where should you start? You should start with the formula, right? So I'm sure most of you got the formula part right. Yes. So what is the formula? 1 minus 1 over 4 squared multiplied by 100%. Yes. So 1 minus 1 over 16 times 100%. That is 93.75%. You can round it to 94, that's fine. You know, accuracy 90, so I'm going to keep it as 93.75%. When you do the homework or in the test, they will explicitly state that rounded to this value. So if they ask you to round, go ahead and round it. Otherwise, keep it as is. Great. We've found the number, but who can interpret this properly? Go ahead, Emily.
So that means that 93.75% of the data will be within 3 standard deviations.
That's right.
Okay, 3 standard.
No, 4 standard.
4 standard deviations. And that's 3, so it would be 12 on either side.
12. Okay. So the answer was 93.75% of the observations will lie within 4 standard deviations from the mean. So the average is 82, right? Yeah. 4 standard deviations would mean 4 times 3, which is 12. What is 82 plus 12? 94. 82 minus 12? 70.
Wait, how do you get 12? How do you know that? Or why do you know?
4 times s. 4 multiplied by 3. How many standard deviations, would you go from 82 to 70? K is 4. 4 standard deviations. Each standard deviation is 3, so 4 of them would be 12. So 12 standard deviations on this side, 12 standard deviations on that side. So within those 2 limits, according to the theorem, right? So within 70 and 94, at least 93.75% of the scores will be hit. So if 100 students took the exam, how many of them will have or would have a score between 70 and 94? 93.75. What happened? That arm got chopped off? Yes. Or a student? Could be. But you get there to 93.75 if you round it to 94 students. So 94 students out of 100 are expected to have a score between 70 and 94. Based on this, would you think the class is relatively easy or hard? Easy. Easy. If someone's going to fail, what are the chances that the person is going to fail? Not a lot. Technically less than 60%. Yes.
We're doing the average minus 40.
Yeah, all times S. S is standard deviation. S. and that is X bar plus.
Wait, but how'd you get 94? X plus
82 plus 4 times R8. What is 82?